Okay, this is the second part of Chapter 5. And the first thing we have to do is all the library commands to get all of our packages loaded. This is just copied from the Part 1 notes. And then I've got all this stuff here that we use to do data manipulation in Part 1. And this is all really just copied from the Wimberley text. Okay, so here we start with the new stuff. We're going to do a spatial join. And we're going to create a data frame called county point. And it's st underscore join, t point underscore 16 underscore 21, comma, OK county. It's going to get there's going to be a row in this join data frame for every tornado. And it's going to have, along with the data for the tornado, the county in which the tornado is located geographically. That's why it's a spatial join. And here we can look at the structure of the county point data after we're done. You can see that you've got the tornado and you've got all the county stuff. Okay. Well, I want you to try reversing the order of the arguments, and this is not something you can copy out of the text. You have to just do it. So put OK county first and t point underscore 16 under 21 second, and see what happens. Okay. So stop the video and please do that, and then come back and start the video again when you're done. Okay, you're back. So let's take a look. And here's what happens. st underscore join OK county t point 1621 looks very similar. Pretty similar anyway. So why are these different and how are they different? Let's take a look again. Let's go back and take a look at those things. Take a look at this. Then take a look at this, and you might see that what happened is that you got there are 434 rows when this is first, and 436 rows when OK county is first. So why are they different? Think about that for a minute or two, and after you've come to the answer, start the video again. Pause the video while you're thinking, of course. Okay. Two more rows in result when OK county is the first argument. If you have t point 1621, you're guaranteed a row for every tornado. The second version guarantees a row for every county. So by default, when you do a spatial join, it is a left join. And here's a link to a place where you can go to read all about spatial joins. Okay. So count the tornadoes in each county. And all you have to do is copy the code from the text, but I'll give you a few minutes to do that. So pause the video while you go get the code from the text and copy it into your work. Okay, you're back. I assume you're done. And here's just the code that we had. You do a county summary as well. First of all, you have to actually drop the geometry from the county point thing so that you can work with it in dplyr. And then we've got county sum is county point, grouped by GOID, summarized t count is equal to n, glimpse of county sum, and now you have for every county, and you represented the counties by GOIDs. You could have represented them by county anything that identifies a county. So County 40001 had 6 tornadoes, 4005 had 3 tornadoes, and so on. Okay? So we're going to make a map now. And you can either map the county or the density of tornadoes in each county. And I want you to just copy the code from the text, and then we'll work with it. And of course, stop the video for a few minutes while you're doing that, and then come back after you're done, and we'll look at the result. Not a very deep metal lift. You just have to copy the code from the text. Okay, let's go on. And there's the code. And here's the county map. Now the only thing is I changed the code just a little bit. I made the outline of every polygon, which is the visual attribute color as opposed to fill. Color gives you the color of the boundary, and fill gives you the color of the internal. Okay, and there's our map. So there are some questions that come up when you look at that code. What's the period for in replace is.na parentheses period comma 04? And the second question that probably comes up in your mind is, how do you use units in R? Okay. Well, I think it would be a good idea for you to try to answer those questions. How would you do that? Think about that for a few minutes. Do some research and see if you can figure out why this dot is here and what this code is. What the code obviously does is to replace NA values with 0. But why do you need this period? And then what is this units thing about? Okay, stop the video. Okay. So for the answers, I'm not going to deliver them. What I want you to do is to go ask ChatGPT what those things are about. Okay? We can talk about this next week. Or maybe I will show you later. Okay, so on we go. So the next step is to make a map using centroids. And I want you to show the count of tornadoes, or possibly the density of tornadoes, by the size of the centroid. And again, this is really just code that you have to copy from the text and look at. And stop the video while you get that done. Okay, you're back, so let's take a look. So we get the centroids with the st_centroid function of county map. And then we overlay the centroids data set with the size equal to the count of tornadoes with the boundary file. We just have the GM_SF data is OK County, and fill is NA. And theme_void. And that gets us a map that looks like this. Now you can see that the size of the dot in each county tells you how many tornadoes occurred in a county. All the way from 0, looks like there's a couple zeros, like maybe here and here, and up to 16 tornadoes in a county, probably down here. Okay. So again, we're going to, now the next step is to map density as a choropleth. And again, the code to do this is in the text, but then we're going to take a deeper look at the code and see some things about it. Okay, here's the code, and here's the map that it produced. And we're going to look at some things in this code and understand what they're doing. Particularly, we're going to focus on the stuff in scale_fill_distiller. Okay. Suppose in the scale_fill_distiller call we left out expression. What would happen? Okay, well, I want you to try that on your own and see if you can tell the result. Tell me what the result is. So again, stop the video and do this, then come back. Okay, you're back. So what did it do? Notice that I took out the expression thing and I just left the quoted string here. What happens is that when we had expression there, it took km:2 and it interpreted this as being that this is supposed to be a superscript. But when you take expression out, you just get exactly what you said, which is km:2. Try some alternatives for the palette. And in the textbook, you see the all of the palettes that are possible. And try one or two of those. Okay? You should probably take about 3-4 minutes to do this. So stop the video while you're doing that, and then we'll come back and I'll look at something that I picked. Okay? Okay, you're back. Well, I chose red purple. This is the only change I made. And now the map looks fairly different. Same map that was yellow, orange, red before, but now it's red, purple. Okay, see what else we could do. What happens if we drop the breaks equal thing? Go ahead and do that on your own. See what the result is of dropping the breaks equal thing. And again, of course, stop the video. Try to drop the breaks equal thing. Then come back and see what I did. See the result that I got. Okay, you're back. So, you notice any difference? Well, I'm not impressed with any significant differences. It really kind of looks much the same to me. Nothing really big. Okay. What happens if we drop direction equal 1? And again, stop the video and drop direction equal 1 and see what happens. Okay, you're back. Ooh, that's a huge difference. What happens if you drop the direction equal 1 is that dark becomes low and light becomes high. And that is the default with all of the ggplot2 stuff, which is, I think, some sort of strange, weird taste of Hadley Wickham, who created this stuff. To me, it is just natural that light is low and dark is high. Okay. So that's all for this. I think I'll have a little bit more to add later. Okay?